Beginning of this section, we did have a couple results. Remember, as theta approaches 0, sine theta over theta, that turns into 1. We also derived a cosine version, but I said as long as you know the sine version, you'll be okay. So if I gave you this problem, can you just plug in 0 for your x's? No, because you get the sine of 0 over 0. We can't evaluate that. But we know the limit as theta approaches 0 of sine theta over theta equals 1. And this can actually be extended as long as these expressions are the same. Then we can continue to say this limit would turn into 1. So if I look at my problem, I have a 7x in my argument. I can't change that. So in order to be able to use this property, I would have to have a 7x on the denominator. So here's what I'm going to do. So the limit x approaches 0. What if I multiply this thing by 7 over 7? We could reorder this a bit. Okay, so then on my denominator, I could put 7x here and pull the 4 over here. Because we know multiplication, we can switch the order. All right, mathematically, this is the same as what we started with. The 7's cancel. You get sine of 7x over 4x, so it's the same. But limit laws say now you can do the limit of each piece. As x approaches 0, 7/4 would go to 7/4 because it doesn't have an x in it. Over here, we're still getting sine 0 over 0, but because the argument and the denominator are the same, we can use this property and say that turns into the actual value of my limit is 7/4. Questions on this one? Let's look at this. Limit as x approaches 0, tangent 3x over x. Okay, I can't plug in 0 because I just get 0 over 0. So let's start rewriting this. Tangent is the same thing as saying sine over cosine. To divide by x, it's the same as multiplying by 1 over x. If you multiply by the reciprocal. Does everybody see how this is the same as tangent 3x over x? If I'm going to use my property, I would have to have sine of 3x over what? 3x. Okay. So let's kind of reorder things. I'm going to pull my x under my sine, and I'll take my cosine over here. So if I need this to be a 3x, we have to put a 3 on top as well. We multiplied by 3 on top and bottom. And I just kind of separated my fractions, so there's one fraction with the sine expression I'm getting and one fraction with everything else. Okay, what does sine of 3x over 3x approach as x is going to 0? 1 times 3 over, what is the cosine of 0? Be radical 4 over 2, which is 1. That's why it's legal, I'm no longer getting 0 on the denominator. So 1 times 3 over 1. Take a second and see if you can figure this one out. Did you get an answer? Mm-hmm. How did you write it?
Sine theta over theta times sine theta over theta.
Yeah. Sine squared just means you have sine times sine. Theta squared is theta times theta, so we can make 2 sine theta over theta fractions. And theta goes to 0, we have 1 times 1, which is 1. All right, any questions on that one? Let's look at this one. Okay, I can't just evaluate at the beginning because I'm getting 0 over 0. So let's kind of separate this. I have to get a sine 2z over 2z, right? Okay. I currently have a z on the bottom, so I'll keep that with my sine. I'm going to pull my cosine off into another fraction. So what do I have to multiply by on top and bottom? 2. So I'll put a 2 here, and I'll multiply this fraction by 2. So as z goes to 0, sine of 2z over 2z would turn into 1 times 2 over the cosine of 0 is, so 1 times 2 over 1 is 2. So far, so good?
At least the answer.
I know, isn't it refreshing?
Yeah.
Like, we're getting numbers again.
Yeah.
Don't worry, tomorrow I'll change it.
Oh.
Nice, lovely expressions, but it's kind of refreshing to be doing some algebra.
Yeah.
How would you guys rewrite this one? Or what would you do first, I guess?
Break apart that top one into 2 separate fractions.
Mm-hmm. Okay. And then we're just looking at our denominator and deciding where to put it. Theta squared, what would I do with that?
Put 1 each side.
I'll put a theta under each of them, that's theta squared. Do I need the cosine theta? No, so I'm just going to pull it off into a different fraction. If I multiply this together, you do multiply tops, multiply bottoms, you get the same thing, so we have not changed our problem. In order to evaluate sine 3 theta over theta, what do I need on the bottom?
3 theta.
So we need to multiply by a 3 on top, and I'll put it in my fraction over to the side. What about this one? So what else would I have to multiply by on my top over here? Remember.
Multiply by 3 twice.
Yeah, because I need to add a 3 on each denominator. So if I add 2 3s on the bottom, I need 2 on top. So sine 3 theta over 3 theta, if theta is going to 0, that goes to 1. Same thing here. Over here, we get 9 over, what is the cosine of 0? So 1 times 9 gives me 9. You guys doing?
This is the best ever.
So you have to have a 2 theta on the bottom, which means you need another 2 on top. So 1 times 2 is 1. All right, let's try this one. Ooh. Ooh. Okay, first of all, can I just plug in my 0?
No.
No, because I get 0 over 0, and that doesn't work. It's not even really set up to do like sine of 2x over 2x, is it? But it is legal to multiply both the top and the bottom by the same thing. So if I need this to be a 2x over 2x and a 5x over 5x, what do both of them need on their denominator? X. So let's multiply top and bottom by 1 over x. So that gives me a sine of 2x over x on top, 5x over x on the bottom. This is written a little bit differently, but we can still get it. I know this needs to have a 2x on the bottom. So we would have to be multiplying by a 2. This one I need a 5 on the bottom, so to cancel that I would have to multiply by 5. Another way of writing that, sine 2x over 2x over a sine 5x over 5x times 2. Now with limits, we know we can do the top and the bottom. The limit of the top, what's the limit as x approaches 0 of sine 2x over 2x? 1. Limit of the bottom as x approaches 0, sine of 5x over 5x? 1. Times 2 over 5. And so we get 2x. One more. Limit as x approaches 0 of x cotangent. I can't just plug in my 0 because cotangent 0 is undefined. Any ideas on what we could do? You can make it 1 over tangent. There might even be a better option because I don't have any identities with tangent, do I?
Cosine over sine, cosine, cosine.
So, we can put this 9 over here. I haven't proven it, but the limit as x approaches 0 of x over sine x also goes to 1. Here's your little justification if you don't believe me. That would be the same as saying 1 over sine x over x by reciprocals. So then limit of the top is 1, limit of the bottom, sine of 0 over 0 goes to 1. So it still goes to 1. So then I could say this goes to 1 times, what's the cosine of 0? Cosine is 1. You guys had some homework last night, so I probably owe you a little more class time today. So, any questions about this? So your assignment, or actually, no, this one, I did the worksheet instead of day 2. So, these problems, and you guys have quite a bit of time right now to get that done.